Now let me add some applications of integrals. When we actually divide one integral by another, we can use that technique to calculate averages of things. So let me explain that. Imagine that we go back to this example of a rod, which has a density, which means kilograms per meter, that changes with x. Okay, so this is a rod that is heavier here than here. Okay, maybe it's a trunk of a tree and the density is higher on one end or whatever. And then I ask you, okay, but what is the average density of this rod? Okay, so average, calculation of averages. So first of all, what do I mean by average density? So what I mean is that so let's call it lambda av. Okay, so this is a constant that does not depend on x, which could act as the, let's say, like the effective, it's the density that a rod should have in order to have the same mass as our original rod. Okay, so if we had a rod with average density constant like that, and we want to calculate the total mass, so the total mass of the rod is equal to the average density times the total length of the rod. Okay, in other words, we could say that the average density must be a constant equal to the total mass divided by the total length. Let's add total here. And this will be a constant such that if we change our rod that has varying densities along its length, we change it by another rod that has a constant density, the total mass is going to be the same. So that's, in that sense, that's why this is the average density. And it's calculated by dividing the total mass by the total length. And the total mass is this integral, and the total length is this integral. So let me write it like this. Is the integral of the density dx divided by the integral of dx alone. Okay? So this is just an example for density. But in general, you can use it to calculate the average of anything. Okay? So the average of a function f average is equal to the integral of f of x with respect to x divided by the integral with respect to x. And what is the meaning of this average here? So think about functions. Let's go back to our picture of functions as graphs. Yeah. So we have some function that is doing some crazy things like that. Yeah. And we want to find what is the average of this function between a and b. So the meaning of this is to find some constant value which is kind of like the average. In which sense is it the average? So it's the average in the sense that the area behind this rectangle would be the same as the area below the original graph. Okay, so the total areas are the same. Okay, and that's why you can calculate this average f average, which would be this typical height of the function f. You could calculate it as the area divided by the length. Area A divided by the length, which is b minus a, which is equal to the integral of f of x dx divided by b minus a, which is the integral of dx. Okay, which is exactly what I wrote here. So that's the calculation of the average of a function. There is a slightly more nuanced concept, which is the concept of a weighted average. Of a function. Okay, and the weighted average of a function is a little bit more difficult to explain, but it's easy to define. It's just the integral of f of x times a weight function w of x dx divided by the integral of w of x dx. So this is like doing an average of a function, but instead of giving equal importance to every value of x, may we say that we care more about values of x that are near above 2. So then the weight would be a function that is bigger when x is above 2. Okay, so it's a way of calculating an average where the importance of certain parts are more important than others. Okay, and this appears, for example, when you want to calculate the center of mass of a rod. Okay, so let's do an example. Center of mass. So the center of mass is nothing else than the average position of the rod, right? But we need to take into account that some parts of the rod weigh more than others, and therefore those parts should count more when calculating the average position of the rod. Okay, so the center of mass is equal to the weighted average. Let me write it explicitly. The center of mass, x center of mass, is equal to the integral of the thing we are averaging, which is the position, x, but weighted by the density, lambda of x, with respect to x, and then divided by the integral of the weights, which is lambda x dx. Okay, so this will be the center of mass of a rod with linear density lambda x. Okay, if you removed the weight, if you removed lambda, then you would be calculating the integral of x dx divided by the integral of dx without lambdas, and that would just be the geometrical center of the rod. Okay, so it would be the midpoint. If you are between a and b, it would be a plus b divided by 2. But if you add the density, then you are doing a weighted average of the position. Okay, so that's the application of weighted averages. And of course, the same that we can do all of this in one dimension with one-dimensional integrals, we can also do it with two-dimensional integrals. So for example, the weighted average of a function x and y with weights w of x and y, that will be calculated as the weighted average of f is equal to the double integral on a certain area of fxy times wxy dx dy divided by the double integral on the same area of just the weights. Okay, and I do not need to copy the equivalent expression for the average, because the average is just the weighted average when the weight is equal to 1. You can see that if you substitute 1 here and here, you end up with this. Okay, so also here you could calculate the average of a function just by setting w equal to 1, and that will be the average, for example, the average density of a plate. Okay, and you can also use it to calculate the average position, the center of mass of a plate. Okay, so let's say that the center of mass is equal to the center of mass in x and the center of mass in y. Okay, so now the center of mass along x, so let me write this. So the center of mass in x is equal to the weighted average of the density using as weight, is the weighted average of the x position, that's the quantity we want to average, weighted by the density with respect to x and y, divided by the double integral of just the weights, which are the density. Okay, and similarly for y. So this is the weighted average of the y position multiplied by the density divided by the double integral of just the density. By the way, there would be a nice simplified way of writing these two equations as a single equation. If you remember back to last chapter, we could do integrals of vectors. We can also do multiple integrals of vectors. So one way you can write this is to say that the center of mass vector, which is this two-dimensional vector, is equal to the double integral of r which is a vector with two components, x and y, times the weight, divided by the double integral of the weight. Okay, so this would be how you could calculate the center of mass of a plate. And we can write these two equations. They are summarized into one single equation by the rules of integrating vectors. Remember, you can just integrate the two components separately, and the answer is a vector. That's why the answer has two components. Okay? So this is calculation of centers of mass. There are some examples of these calculations in my notes. Okay, I don't want to go through them in videos, but you have examples in the notes. So see you in the next video.